In Fusion, when you are working on images that have an alpha channel, there is a very common issue that you might encounter. That is that you suddenly observe edges which are too dark or too bright or look jagged, or you may even find color values in areas that you thought were fully transparent. This is very often related to a concept called alpha premultiplication, and it comes from color correction operations on images with transparency. To fix this issue, Fusion has a checkbox called pre-divide post-multiply, which you find in the color correction tools. So in this tutorial, I want to give you a better understanding of what that checkbox is really good for. I want to show you how you can spot the issues that lead to this, and I want to dive a bit into the background theory of what alpha multiplication actually is, so that you understand a bit better where this is coming from and how you can troubleshoot your compositions for this. So, hope this sounds good. Let's have a look. Let me start with a very simple compositing example. So I have here this image of the tent and have already masked it out. The alpha channel, I'm showing you the alpha channel here on the right side. So black, fully transparent, white, fully opaque is what the output should be. So when I attach the mask, then exactly that is happening. So white area, fully opaque, fully transparent outside. So far, so good. Now let's composite this over another background. And then you may say, okay, looks fine, but the colors aren't matching, and you start doing color corrections of any type, right? Let me bring in a simple color corrector, and any of the color tools will do for the demonstration. And depending on what operations you do, you may see some problems, or it may look fine if you just start correcting. So for example, if I do some hue changes or so, probably I don't see any issue right away. But if I, for example, do a change on the lift, you see that suddenly the background gets impacted seemingly. And let's bring the color corrector on the left viewer, and then you see that actually if I bring the lift up, I'm getting white values here despite the transparency. Let me open the color inspector here. So you see, even though alpha is 0, I still have color values here which then get into the final composition. Or if I go in the other direction, I actually see negative color values here where the alpha channel is 0. So the fact that it's fully transparent is not being considered. I am doing manipulations of the RGB values even though alpha is 0. And that happens with most of these operations, also brightness, etc. If you do a gamma correction, for example, gamma correction doesn't impact 0 values, right? So it only impacts values in the mid-range. But if you zoom in here or here, you may still see an issue. You may see that the edges here, you suddenly see like a very rough and dark edge. Now it's supposed to get a bit darker, but still this seems to be wrong here, if I look at the edge. And for both of these issues, it is related to this particular checkbox here, which says pre-divide post-multiply. And what is being divided and multiplied is exactly the alpha channel. If you check it, you see already the edge problem here. So dark edge goes away, right away. And equally, if I now let's undo the gamma and do a lift operation, for example, you see now it's only impacting the tent and not the transparent areas at all. So if you just need a quick fix, that's probably your quick fix. Let's still look at another example. So compositing is one case, keying, it may happen there. Also with graphics, I actually have a title here, so if the title is coming from Fusion, I can of course do any color changes here, but if it's coming from Photoshop, or you load a file, you may often be doing color corrections there. So let's say let's do a curve tool for an example and pull a bit in the middle. Sorry, let me turn off the alpha, so I only change the color. I don't want to change the alpha channel, and let's pull this down a bit. Okay, from a distance it looks good, but what if I zoom in? You see here the edges. So before the edges looked pretty okay. If I bring this down, they start to look really ugly, right? And the same if I go up, you may see like either some form of bright halo or these jagged edges. In both cases, this checkbox fixes it. So if all you need is identify the problem and fix it, then here is your solution. But if you want to understand a bit more, then let's have a deeper look at how alpha channels are actually applied to images, how masks are actually applied. So let me go back to the example here from my tent compositing example with the alpha channel and the tent. And when I apply this, what does actually happen? So let's check by manually applying this with a channel Boolean operation. So just for demonstration, I bring a channel Boolean in here. And channel Boolean can mix channels, as the name suggests. And in this case, I connect a foreground and a background. And now I copy only the alpha channel into the background. So I say do nothing, copy, do nothing. So copy is copy from the foreground to the background. And I copy the alpha from this tool, from my mask. I copy this alpha channel into this image. And what I'm getting now, let's have a look, is this image. That's maybe not exactly what you expect. It is now a combined image. It does have the correct alpha values. And I can open the inspector here so you can see the alpha values. So here alpha 1, here alpha 0. But it still has all the color values as well. And the way the Fusion viewer displays it, it displays the checkerboard for the transparency and puts the color values on top of it. If I use this now in compositing, let me delete my previous step here. If I use this in compositing, I also get the values mixed. So I get like very bright values here because all the RGB values are still there. They're getting mixed in. So this image is what is called an unpre-multiplied image. So it does have the alpha channel, but it's called unpre-multiplied, which is a really strange word, but it is called that way because the alpha channel was not yet multiplied in. What you expect is that actually all the color values are being numerically multiplied with the alpha values. And what then happens is that wherever alpha is 0, you get 0 also in the color values. Wherever alpha is 1, you still get 1 also in the color values. And in the semi-transparent areas, what happens there? Your color values actually get darker as your transparency increases. And this makes a lot of sense. If you think about if something goes to transparency, it's not just that you can see through, it's also that less light comes from the object, right? So if something fades into transparency, or if you look at a transparent piece of paper or window glass, whatever, if there's transparency, it means you can look through. You have a mixture of the RGB values. It also means the object itself is less visible, less light is coming from the object. And so far this is not happening here, but if we multiply, then it's happening. In principle, we could multiply directly in here. We could, instead of copy, say multiply, and then I would need to set this all back to alpha so that the alpha channel is multiplied. Alpha foreground, like this. And something is missing. Oops, background, alpha foreground. And now I am getting what is expected. So my color values are being adjusted for the alpha values. There's actually another tool. Let me undo this. Let me go back to this. So let me go back to the unpre-multiplied image. Another tool is you have a tool called alpha multiply, and that is directly in Fusion. It does exactly the same thing. So it does the multiplication on this image, and it brings this image to this image, right? So it performs this multiplication. In principle, you wouldn't have to do this. It is possible to do compositing with unpre-multiplied images. Has been done in the past. It's possible. There's nothing wrong with this. You might even say that maybe there's an advantage of keeping the color values. So, for example, if you come from an external application, you have created your alpha channel, but maybe you want to go back, or change the alpha channel, expand the edges or so, and still want the color values. It could be an advantage to have it this way. And in theory, you could be doing compositing this way. Let me remove the alpha multiplier, put it to the side. If you wanted to do compositing this way, you would actually go into this subtractive additive slider and move this from additive to subtractive. And now the merge works based on unpre-multiplied alpha. So other tools might have a checkbox whether the alpha channel was pre-multiplied or not. In Fusion, the standard is you assume it was multiplied. That's the standard assumption of the tools. That's the standard assumption of the merge node. But this slider actually switches between was it multiplied or was it not multiplied. So if you put it to subtractive, then you get the correct result without the previous alpha multiplication. So these are the differences between the unpre-multiplied and pre-multiplied alpha channel. Let's see now what is the impact if I do color corrections. Let me go back just for illustration. I bring the alpha multiply back in which case my merge should be set to additive. And now if I do a color correction of any type, let's say brightness and contrast, for example, where do I need to put it? Do I put it before or after the alpha multiplication? And the answer to that question is basically the impact of this pre-divide post-multiply checkbox. So if I put it after the alpha multiplication, I'm doing color corrections on this image, and we saw already before that this can be a problem. So if I do my lift operation, it's working on the alpha channel here, etc., right? If I do it before the alpha multiplication, then here the whole image is impacted, right? So my lift is happening on the background as well, but then afterwards the transparency is being computed in the correct way, and that solves the problem. So if I was manually bringing in an alpha channel, I could just make sure that all my color corrections happen before I bring in the alpha channel. Or if I bring it in like with this channel boolean and haven't multiplied it yet, I could do all my color corrections before I multiply and thereby avoid the issue. However, let's go back to maybe the more common issue where the alpha channel is already applied. And in this case, you have to kind of undo the alpha multiplication, and you might guess there is a tool for this, and it's called alpha divide. Let's see how that works. And in order to make this flow a bit simpler again, let me again go to the place where we were in the beginning. So I'm just applying the alpha channel like it's applied by default, which is the pre-multiplied version. And then I can divide by the alpha channel to bring a pre-multiplied image back to an unpre-multiplied image. First, let's have a look. So let me bring this alpha divide in here. What does this do? Well, from a distance, you won't see much, but you see something if you go into the semi-transparent areas. So this was before. This is the normal image, like the pre-multiplied image, the image which you just get by attaching a mask. And then if you do alpha divide, you see something is happening here on the edges. So in the edges, you have semi-transparent alpha values. So alpha values of, let's say here, you see alpha 0.23, 0.01, and basically Fusion is dividing by those values and thereby making sure that the color values are coming back to how they were before the alpha channel was applied. Now, outside here, where it's fully transparent, where the RGB values are 0, there is no way mathematically to bring them back, right? And division by 0 is not defined, so it doesn't make sense to divide by 0, and the tool doesn't do it. So in areas where the alpha values are 0, it just remains 0. RGB values remain 0. But in the other areas where you have semi-transparency, especially across the edges, there it's restoring the original color values. And then on those original color values, I can now do color correction, whatever I want to do, lift, gamma, gain, whatever. And then afterwards apply, so do the multiplication again, and then do my compositing with the pre-multiplied alpha. And this step, division, color correction, multiplication, this step is simplified by this checkbox. So here it's pre-divide, post-multiply, just one checkbox, or under the curves tool, you find it here. In the color corrector, you find it under options, pre-divide, post-multiply. It's all doing the same thing. It just says first divide, then do the color correction, then multiply again. And if you don't want to do it with individual nodes like I have done here, you just click that checkbox. Now, the individual nodes might make sense if you want to do like a lot of color corrections in a row, or if you do some other more manual type of interventions, then this is how you would do it manually. This can also happen in keying problems, for example, if you have some advanced keying algorithms, and I'm showing you some of those in my compositing course. It can also happen there, and sometimes it just makes sense to manually, multiply at the end. I know this whole topic can sometimes sound a little bit theoretical, and I want to offer you one more type of explanation with a tiny little bit of mathematics, just because I feel it makes sense to look at this topic from more than one angle to internalize it. I can demonstrate what is working, but sometimes it's good to actually look at the numerical values and in a more theoretical way see what is actually happening, and then you get a better understanding of why those color correction operations actually need to consider the alpha channel. For this, I have created a very simple example here with a blue sphere. Where is it? Here it is. And I might composite it over a different color background. And in this case, I am actually on a very low resolution grid, just 100 by 100 pixels. And the reason for this is that in this case, we can actually see individual pixels. So let me turn off the smooth resize. That's a viewer option to interpolate pixels. If you turn it off, you can actually see here, if you zoom in, you can see individual pixels. And for now, so this is with a bit of soft edge, but you can manipulate this. So if you have no soft edge, you still see that pixels are automatically across the edges being interpolated. So if you have a straight line which doesn't perfectly align with the pixel grid, or a curved line here, then you get semi-transparency, just so that this line is, interpolated across the nearest pixels. So this is basically anti-aliasing what is happening here. And this is also a reason why edges may sometimes look jagged once you do color corrections. So let's bring in again a brightness and contrast here and do some gamma correction. And let me bring this in, not that extreme, but now you see there's something happening on the edges here, and here they look a bit too dark. If I enable it, you see those edges look brighter again. And if you look a bit from a distance, it's possible that you see like these edge artifacts, or maybe against the background it's maybe easier to see. And also here I disabled the smooth resize, so you suddenly see some form of jagged edges, which when you turn this on look a bit smoother. And let me increase the softness a bit, then it's maybe again a bit easier to see. So you may see that, here you see that there's like a dark edge kind of crawling in. Now let's look specifically at this edge and look at it with a few numerical values attached, and I show it to you on a presentation instead of here, because then I can annotate with a few numbers. So here is my little academic example with values for blue and alpha. So in the center, where my sphere is fully opaque, there I have blue values of 0.8, because that's how I designed the sphere. Outside, where it's fully transparent, blue and alpha are 0. But at the edge, at some point at the edge, I have 50% alpha, so 50% transparency. And in that point where I have 50% transparency, I would expect that the color value is also giving a 50% contribution, right? So when it was 0.8 for fully solid, if I can 50% see-through, then it should reduce by 50%. So the blue contribution in this pixel should only be 0.4. And that is the case. You can test it in Fusion yourself. This is coming from Fusion, so that is the case. Now, if I do color corrections on this, and in this case I do a brightness increase by 0.2, you can do it with the brightness and contrast tool, then let's see what happens. So I have 1 in the fully solid area, I have 0.2 outside, because it's just adding 0.2 everywhere, and I have 0.6 in the 50% semi-transparent areas. Now we immediately know that 0.2 outside is not desired, right? Because alpha 0, we want nothing. But also here in the middle at 50%, it's not correct, because the blue contribution is no longer 50% of the blue contribution here. So you can numerically see that this brightness operation doesn't make sense without considering the alpha channel. And that's the case for all the brightness contrast operations, basically gamma, gain. So all of them need to consider the impact of transparency in order to do color corrections correctly. So the correct way, what you would expect is you add 0.2 here, that's fine. You don't add anything where it's 0, and where it's 50%, it should still be 50% of the full value afterwards. So here it just needs to go from 0.4 originally to 0.5 in order to still relatively match, considering that it's 50% transparent, right? And if you go to the unpre-multiplied image, then you do not have this problem, because unpre-multiplied, you just do the same operation, add 0.2 everywhere, but in the semi-transparent area, you go from 0.8 to 1, same as in the fully transparent area. So there you don't have any problem. Outside, you're also increasing, but that's not a problem either, because once you multiply, all this goes away. And here you are applying the alpha channel like if there was never an alpha channel before, and now the way you apply it, it's applied correctly. So your color corrections work correctly again. So this was another angle to look at this rather technical topic, but it is a very fundamental and important topic for compositing, for motion graphics. I feel it's really good to have this kind of background understanding. If you are hungry for more, have a look at my compositing course on vfxstudy.com, where I look at some of those topics. But if you have a very specific topic where you say, hey, I always did it this way, I always used this tool, but I never knew why, let me know in the comments. I can make more such tutorials on YouTube as well. So see you next time. Click like and subscribe, and thanks for watching. Cheers.